Hello everyone. Good evening, all of you. Uh, I am Sandeep Dev, the technical support engineer in Ram Caddsys Private Limited, and I'll be uh, I'll be giving the explanation on the cold form steel automation using Strap software today. And today we have Mr. Srihari Desai with us. He is the technical manager at Structured Design and Engineering, and he is having 10 years of experience in the field of LGSF, and he has worked on 300 plus projects worldwide. So we will also hear from him his experience and what are the different approaches of cold form steel design in this industry. So I think so we can start the session, right?
Yeah, sure.
Yeah. So let me share the screen. I hope it is visible to all of you. Just... So, in today's webinar, let's see what are the topics that we are going to cover. If you see here, first of all, we'll talk about the geometry. We'll see how to create the process of node creation and edit. We'll see the geometry using beams, the member properties. We'll also see how we can create user the sections using our cross-sec module. We'll see how to assign the releases and restraints, and how we can check the section orientations, and how we can use the local axis. So after that, we will see the loadings, the basic loadings. That means the gravity loads, the wind loads. We'll see the automatic wind load generation process. We'll see how we can define the seismic load on the structure, and we can see how we can create the load combinations manually and automatically. Then we'll analyze the structure, and we'll see the analysis results and the post processing. That means we'll be seeing the moments, the shear forces, all these things. After that, we'll go for design. In that, we'll check the default design parameters. We'll see different parameters like effective length factor, the torsion, the inclusion of torsion. Then we'll go for auto design optimization, how we can do that in Strap. We'll also see the detailed design results of the structure, and also we'll go for capacity check. Then in Strap, we will check the sway, that is the lateral displacement of the structure, and we can also see how we can optimize the structure automatically to control the sway. After that, in Strap, we can go for BIM integration also. That means we can import the files from different softwares or different models, 3D models. You can see we have, we'll be importing the .std file in Strap, and we'll also show you how we can import the IFC files from Vertex BD or any other framing softwares in Strap for the analysis and design. So these are the topics we are going to cover in this webinar. So let's get started. So here, when you will be opening the software, this screen will be coming first. This is nothing but the model list. Here you will find all the models that you have created, its name, the date of modification, and the date of solving. Actually, when you have solved the model, you have analyzed the model, the date will be mentioned here. And along with these information, you will have a preview of the model also. So it will be easy for you to open the particular model you want. So now I'll be opening a cold form prefabricated 3D cabin. So if I open this, I'll go to geometry. You can see here we have created this geometry. Here in this top menu, you can see we have options to see the node numbers, the beam numbers. If you have the elements, means the slabs, then you can see the element number also. Then you can see the property by color. You can see the different properties assigned to different members. It is showing by color. And you can also see the property number, which number of property we have assigned to which section. And you can see the orientation of the members and also the local axes. Then we have view option here. What we can do, we can save our own view also. Otherwise, we have this x1, x2 plane, x2, x3 plane. You can see we have the isometric view, or else we can also set our own view. suppose I'll be creating one view. Suppose this is one view I want to see. So I'll go to this save restore view and save current view. So I'll make it, suppose ISO, it is suppose one view one. Okay, so click on OK. Now I'll go back to isometric view. I'll go here, save and restore view, and I'll click on this one. You can see this, the view that we have saved with the name one, it will be showing you. So this is how we can save different views also. Then we have different other options here available. And in this right hand side corner, we have the creation and edit tools. Like suppose we want to create nodes, right, for this structure. So we'll be going to this nodes, and you can see there are different methods to create nodes. We can create grid of nodes, or we can use different equations also to create the nodes here. And we can delete, move, or unify the nodes. That means the edit option we have for these nodes. Now if you go to restrain, we have different restraints. That means the support conditions we can provide. If you go to beams, then we have creation of beam and the different properties that we will be assigning to the beams. Okay, so using these nodes and beams, we have created this structure. Now after creating the structure, what we need to do, we need to assign the section properties to these beams, right? So for that, under the beams, we have this properties option, you can see here. So if I go to properties, you can see there are different several properties defined, and these properties are assigned to this different members. Now to assign or to define a new property, what we need to do, we need to select any unused section, and if you click on define revise, here you can see we have a separate database for cold form steel sections. So if you select this cold form, and if you go to steel table, here you can see we have C-lips, a lot of sections of C-lips, then we have C-lips back to back, we have C-lips front to front. Okay, and you can see there are different sections which is for the cold form section. So these sections you can always use. Suppose I'll be defining one section, I'll take this one, C-lips, maybe 7541 1.1, click on OK, and you need to select the major axis direction and click on OK. So this particular section will be defined here. Now you can assign this to the beams you want. So if you go to assign, here you can see you have different options, like you can select individual beams where you want to assign this particular section, or you can select to all the beams also. So there are different options to assign the beam section to particular members. Now now you can see the database of the cold form steel that we have. But suppose you want a section which is something different from that one, or maybe it is not there, you want to use a separate section. So what you can do, we have a different module, we have cross-sec module, in which you can create your own sections. So if I close this, let me open the cross-sec module. You can see here we have this cross-sec module. I'll open this. Now here you can create your own sections. Suppose to create one section, I'll go to section and click on new line section. I'll name this maybe C-lips, and here we have, suppose C-lips combined. I'll make it C-lips com. So the screen dimensions 500, thickness I will keep 1, inside radius bend I'll keep 2, and click on OK. Now I'll draw a section here. Now while drawing the section, it doesn't matter what dimensions you are giving here, because the dimensions we can always provide later on. So I'll be drawing one section which is a C section. You can see I have created one section. Now I'll create another section here, and I'll create a combined section. So I'll go to section here and click on add a subsection, the same thickness and inside band radius, click on OK, and I'll create another section here. While drawing the section, you do not have to worry about the parameters, or you can say the dimensions. We can always change it. So I have created two sections. Now I'll create another one. If I go to section, add subsection, now I'll create in this way. So I have created three sections. Now what I'll do, I'll create a combined section using these three. So for that, I'll go to section, and you can see we have these connect subsections. I'll take this bottom one, this bottom joint, and here I'll connect this particular node. And you can see we have created a combined section. Now what about the dimensions? So to adjust the dimensions, what I'll do, I'll create a table. So I'll go to section table and create a table. I'll name it as clips combo. Okay, click on OK. Now here we need to name it. Suppose I'll be creating all the sections with 75 by 40 by 25. Okay, and thickness will be considering 1. So you can also write it if you want. So now here you can see A2, A3, all these parameters are defined here. So you just have to give the values. So automatically it will be adjusted in the main section. So what I'll do, I'll give these parameters. You can see A1 starting from here. So A1 I'll consider 25. A2 I'll consider 40. A3 I'll be considering 75. Then similarly A4 will be 40 and A5 will be 25. So one section we have done, the thickness and radius will be same. Then we'll start the second section. You can see the A6 means this one. So A6 will be 25, A7 will be 40, A8 will be 75, A9 again 40, and A10 will be 25. And then again thickness and bend radius. Then for the left hand side section, A11 you can see this one. So I'll be giving this a name as 25. A12 will be 40. Then A13, if you see the total depth, so it will be 75. A14 will be 40 and A15 will be 25. So this is how you can give all the parameters. Now I'll click on OK. So we have created the section. Now what we need to export this section to strap so that we can use this in our model. So for that, what I'll do, I'll go to section table, and you can see we have this option, transfer to strap. Select this clips com. The dimension we have used in millimeter unit, so I'll keep it as millimeter. Now click on OK. So you can see a message is showing you one section were added to strap cold form table. Now click on OK. Now let me close this strap, and let us open the strap again. So I'll open it now. I'll go to the same model, and here I'll go to beams and properties. I'll select any unused property and define revise. I'll select cold formed and steel table. So here you can see this clips com is added here, and under this list we have this 75, 40, 25 section. So you can see the combined section here. Now if I click on OK, you can see the major axis direction you can select from here. So I'll click on OK now. So just to show you, I'll be assigning this section to any of these members. Suppose I'll click on assign individual beams. So I'll assign in these members. Okay, now click on close. Now to see this, whether we have assigned it properly or not, you can see the display section orientation, and you can see how we have provided here. Though it is not required here, but just to show you, in some places maybe here it might be required, but just to show you how we can assign these members. So to get a proper view of this, what I'll do, I'll select this member, I'll go to remove and display selected only, individual beams. I'll select these members. Here you can see. Now I'll go to the rendered view, and you can easily see the section. Okay, this is how you can create a section of your own, and you can assign this to your to the model. Okay, so now so you can see how we have assigned this section. I'll undo this. Okay, now you can also change the orientation of any member using this local axis option. If you go to local axis, there are different options to change the orientation. We have beta angle option. You can define the x2 plane, or you can change the invert flange location also. So let me show you. If I use this invert flange location option, individual beams, I'll select these two. You can see it has inverted the flange location. So this is how you can change the orientation of the members also. I'll undo this. So in beams, we have the member release option. If you go to releases, you can assign the moment releases, or you can also make the bracing members as tension only or compression only. Now we have the assignment method, whether you want to assign this particular criteria at a single beam end or maybe both ends of the beam. So you can assign this to the members. Here you can see we have assigned the moment releases to these several members. So this is how, using these nodes, beams, you can create the structure. We have also elements, slabs, walls. So if you want to create a concrete wall, or you want to create the elements or slabs, you can create from here. You can assign the spring properties also. Okay, or you can copy or delete the members from here. So in this right hand side corner, you have every option to create and edit this the geometry. Okay, so after creating the geometry, if you go to this render view, you can see the whole structure. You can see the properties that we have assigned by color. If you see this view, and here we have this property number. So this property number corresponding to the properties that we have defined here. You can see the numbering is given here. So if you turn on this property number, it will show you the properties as per these numbers, the serials that we have assigned there. Okay, so okay, now after creation of geometry, what we will do, we'll assign the loads. So for that, we will go to loads. If you want to create a new load case, obviously you have it is very easy. You can easily understand we have this new load option. If you click on new load, and suppose I'll be creating one load, suppose dead load, so DL, and click on OK. So now the dead load is created. So under this dead load, now we have only beam members here. So you can assign, suppose I'll be assigning the wall load. So what we have to do, we have to define using this beam loads here. So if you go to define, you can see there are different options. You can assign the uniformly distributed loads. You can assign linearly varying loads, concentrated loads. Okay, you can also assign the self weight of this all beams. So you can do that using this method. Or if you want to assign a area load to this, suppose any area, maybe it is a wind load that you have calculated, and you want to assign it as an area load, so you can use this global load option. Or maybe you want to assign the floor loads on the top, or maybe the roofing material load, so you can use this global load option. If you click on define, you can see you can define the value here, or you can define the load type, whether it is a area load or line load. You can also transfer these area loads to beams or joints. You can select from here, and the load direction you can select from here. So this is how you can create a load and assign the loads on the structure. We have already created some loads. If you go to the existing load, you can see we have created the dead load of roofing material, and this load we have assigned as a global load. We have the dead loads of the wall. You can see these loads are nothing but the beam loads. We have the self weight of all the beam members. We have the live load on roof, and this wind loads. Now these wind loads we have assigned manually using the global load option. Now you also have the option to create the wind loads automatically. So if you go to this wind load option, here you can see we have defined a new wind load case. So I'll click on define a new wind load case. Here you need to select the contour, or you can say which type of loaded area you have. Suppose it is a user defined panel, or a building contour and roof, or it is only roof, or maybe open structures like tower, or if you want to assign the load only a selected beam. So you can select from here. For now I'll be selecting the building contour and roof. The height direction, obviously for us it will be x3, and I'll be selecting all the beams. Now click on OK. Now here what I'll do, I'll define a load case, maybe wind x1. I'll click on OK. Now here, if you are a new user, you do not have to worry about it, because in this area you can see it will be showing you what you need to do next. So it is telling you to select a node at the base level. You can see here. So we'll select a node from here. Now what we need to do, we need to create the base contour. So I'll create a base contour like this. I'll finish it here. Now you can define different contours. If you have different contours in the structure, so you can define different contours. For us, we only have one, so we'll be ending this now. So end building contour definition. Now here you can define the roof type. If it is a flat roof, if you can keep this flat roof, or parapet height. If you want to define, you can define the parapet height also. In our case, it is a duo pitch roof. We also have mono pitch roof option and duo pitch roof. We have the multi-span roof, or if you want to ignore the roof here, so you can ignore it. So for now, we'll be selecting this duo pitch roof. The direction of your ridge, in our case, if you see this global axis, in our case the ridge direction is x1. So I'll select this global x1. Now here, for every wind load case, it will be 4 cases we need to create. 2 with upward and downward for one direction, and 2 with upward and downward for the other direction. The CPI, which is nothing but the pressure coefficient, the internal pressure coefficient, you can get from the code you are using. So for now, I'll be selecting 0.5 as the CPI value, and then click on OK. Now here you can see it is asking to select a node at the ridge. So I'll select a node at the ridge. Now here you can define the wind parameters. You can select the desired code. If you click on code, you can select the desired code you want. We have IS 875, we have Australian and New Zealand code, we have AAC code, NBC, we have Israeli code. So we have Euro code. So you can select whatever code you want from here. For now, I'll be selecting IS 875. The height direction we have already defined. The height of coordinate. Suppose your structure is not starting from the zero level itself. So maybe we have an underground structure, and the wind will be acting from here. So you can define which height, at what height you want to start the wind definition actually. So now the terrain type you can select from here. These types will be given in the code. You can select the building type, or building class you can say. And if you define the velocity, which is nothing but the which is nothing now if you define the basic wind speed here, the pressure will be automatically calculated. Now you need to select in which direction you want to act this load. So in our case, we'll be selecting this plus x1 and click on OK. Now it is asking you to whether you want to create a new load case, another load case or not. For now, I'll click on no. Now we have defined the wind loads automatically. So if you go to existing load, and at the end we have this wind x1. If you select, you can see for all the phases, it has calculated the pressure and it has assigned the pressure as a global load to the structure. You can also see how this global load is acting. If you go to existing load, I'll revise this. If you go to a display, global loads on beams, and I'll show here display load as beam loads, and click on OK. And you can see how this wind load is acting. If I go to this x1 x3 plane, you can see how the wind load is acting on the beams. Okay, so in that case, what we have done, we have created this wind load case automatically. So for all the phases, it has assigned the wind loads. So I'll close this, and we have another wind load that we have assigned manually, which is in x2 direction. So I'll revise this, and so you can see these are the global loads we have assigned. So in that case, if I go to x2 x3 plane, display global loads on beams, display load as beam load, click on OK. You can see how the load is applied. So this load is applied on the beams. You can see here on all the beams and columns. Okay, so now click on end load case. Now if you want to check the sway, or you can see the lateral displacement of the structure. So you can also do that. If you go to sway, you can see we have added a couple of joints here. These joints are nothing but, if you turn on this node number, you can see these numbers are mentioned here. So if you go to sway, you can see you have selected the node number 25 for x1 and x2, node number 29, 26 and 30 for x1 and x2 direction to check the lateral displacement. So you can also add any number here, any node here. Maybe I'll delete one from here, and I'll show you how we can do that. So suppose I'll be selecting this node number 29 to check the lateral displacement along this x2 direction. So I'll click on add. Here we have this sway or drift option. So I'll select sway. It will be along x2 direction and click on OK. So I'll select this node number 29, and here you can see this node number 29 is added for the sway calculation. That means it will be showing you the displacement of the structure. So the sway is nothing but a global phenomenon, right? So we'll be checking the total displacement of the structure at this particular node. So I'll click on end now. Now if I solve the structure, so now you can see the different results. If I go to draw results, we'll go to beam result diagram and load case. If I click on OK, you can see different loads and the moments, the shear force in different direction, the axial force. So you can select the dead load. We have this total dead load. So you can see that axial force due to the total dead load. You can also see the values here. Okay, so this is how we can check all the results visually. Now, after completing this, what we will do, we'll be defining the seismic weight and the seismic load on the structure. So for that, I'll go to geometry only, and I'll go to weights. Now here we have already defined the weights. So let me show you how we can do that. Let me turn off this node numbering. If you go to static loads, here you can define which loads you want to include for the seismic weight definition. So here we have added total dead load, which is 100%. You can see the factor is 1, and the live load on roof we have selected as 25%. Now you can select the direction on which you want to take the load component, and you can replace these nodal weights by static load. So I'll click on OK. You can see at every node this seismic weight will be assigned. Now you can also define the mode shapes. If you select this mode shape, the number of mode shapes you can select by yourself. Initially we'll keep it as 15. If the requirement is not meeting, you can increase also. The height direction, in our case it is x3. You can see the global axis. We have this x1, x2 direction. If you want to consider the vertical acceleration, you can also consider this x3 direction. You can also define the eccentricity if you want, and you can calculate the soft story or story shear center. You can select from here. So for now I'll skip this and I'll click on OK. Now I'll click on solve. So click on solve now, and what it will do, it will solve all the mode shapes. You can see 15 mode shapes we have. So here it has solved the mode shapes. If you select this mode, you can see the first mode shape. You can select the mode 2, mode 3, 4, and you can also see the time period for the particular mode. So after completing the modal analysis and assigning the seismic weight, what we will do, we'll define the seismic parameters. So in STRAP, if you go to a seismic analysis and method for combining modes, here is a very good option. You can see we have two methods for combining the modes. We have CQC and we have SRSS method. And the most important thing is this one, missing mass correction. So in our structure, if some mass is missing in the modal analysis, or you can say the modal participation mass, so in that case you can incorporate this mass using this missing mass option. So if you click this missing mass option, it will consider the missing mass in the calculation. So yeah, you can do that here. You can check this and click on OK. Now we will be defining the seismic parameters. So I'll go to parameter. Here also you can select the desired code you want. If you go to select another code, you have this Israel code. You can also define your own response spectra. We have this UBC 97, Euro code, Indian standard code, NBC and AAC standard. So then I'll select this Indian standard IS 1890 2016 for now and click on OK. Now here we need to define the parameters as per our code. So the earthquake direction I'll be considering as x2. The soil type maybe medium. The importance factor will keep 1. The response reduction factor 3. And seismic zone factor, in India we have 4 zone factors. So as per your code, you can define these zone factors, this response reduction factor and all. Now here we have 2 options. One is no scaling and another one is scaling 100%. Now when you will be selecting no scaling, it will show you the unscaled response spectrum. That means the base shear will not be scaled. So you will only see the base shear of the dynamic load case. So if I click on no scaling and click on OK, and then I'll click on update results, it will update the result. Click on OK. So now if I go to display table, display modal results and click on OK, you can see here the mass participation, it is showing 65%, and this is the CQC results, which is nothing but your base shear, and this base shear is nothing but the dynamic base shear. So now I'll go to parameters again. I'll select this scaling 100%. The total weight of the structure will be calculated. This is nothing but the seismic weight, so it will be calculated as per the static load you have assigned. And the time period value, what you have to do, you have to take the empirical formula from the code and you can calculate the time period from there. For now, I'll keep it 0.5 and I'll click on OK. I'll update the results again. I'll go to a display table and display modal results. So as per the given parameters and the time period value, you can see now the CQC results, that means the base shear it is 1.58 and the scaling factor is 1.7233. That means this is nothing but your static base shear. So this is how we can check the unscaled response spectrum, or you can also do the scaled response spectrum here. So now I'll click on close. So we have defined all the loads. Now what we have to do, we have to get the load combinations. So to get the load combinations, what we will do, we will go to results again, and here we have combinations. So here if you click on define revise, I have already defined some load combinations here. So in this list you can define the load combinations by yourself. It is the manual process. You can write the load name, suppose dead load plus live load, and you can give the factors for these load cases. So you have these load cases, you can give the factors, but these load combination we have created using the automatic process, and we have assigned the factors in the load group. So I'll also show you how we can create this automatically. So here you can see we have created one load combination here, and you can give the factor maybe 1.5 dead load, and suppose not here, maybe in the total dead load we have this total dead load, so I'll keep it 1.5, and we have this live load, so live on roof, so I'll keep it 1.5. So this is how you can create your own load combination. Okay, for now I'll delete this as we already defined some load combinations. So these load combinations are created using the automatic process. I'll show you. Let me click on cancel. If you go to combinations, and we have the standard combination library. If you click on retrieve from standard program library, you can see we have different country codes for the load combinations. So we have IS 800, we have BS code, we have ACI code, we have NBC, we have European code, AAC code. So you can select any code from here as per your requirement. Maybe I'll select IS 800. You can also select the specific load combinations you want from here, and you can click on OK. So once we click on OK, what will happen? These load combinations will be added in the list of the load combination. You can see here these load combinations will be added here. Now what we need to do, this load combinations which you have retrieved from the combination library, it has created some load groups like dead load, earthquake load. So and we have created the load cases. So what we need to do, we need to assign the load cases to the load groups. For that, if you go to groups and add and revise group, you can see these are the load groups. So if I click on dead and click on here, okay, you can see I have already included. So what we need to do, in this dead load group, we need to include the load case. So we have created one total dead load case. So all the dead loads will be included here. So if I click on OK, similarly we need to do for the other also, like suppose live. Okay, so you can include the live load here. You can include or exclude the any load here under this load groups. So this is how you need to create the load groups. And once you define the load groups, what will happen in the load combination, as these factors are defined, so these factors will be applied to the load cases that we have defined. So we have done creating the load combination. So after that, what we will do, we'll go for design. So for designing the structure, we'll go to steel. First of all, we'll go to defaults. Here we need to define the default parameters. You can see in the general, we have the allowable deflection limit, we have allowable slenderness, then we have tension area. If you go to steel grade, you can select the steel grade from here, or you can define your own steel grade as user defined. Then we'll be going for cold formed. Here you need to select the code you want to use for the design of your cold form steel structure. So I'll select this AISI specification, load and resistance factor design. I'll click on OK. Now I'll go to sections. Here we have two options. We can give two commands to the software. One is assigned in geometry and another one is type in geometry. So this thing, that means it will check the geometry or check the sections we have assigned in the geometry. And in the second section, what we will do, if I select cold form and if I click on type in geometry, what will happen? The software will automatically select the section, the appropriate section for the structure, and the selection of appropriate sections will be as per the geometry that we have assigned here in all the members. So you can see this type in geometry, the same type of section will be assigned to the members. So for now we'll be going for assigned in geometry and click on select all beams. So if you are selecting type in geometry, in that case you do not want the software to select one particular shape here, another one here, another one here. So in that case it will be difficulty in case of construction, or maybe it may not be possible in case of cold form steel. So in that case, if you want to select identical sections, you can go to identical sections, and if you select this select by property number, and you can select all this and click on OK, what will happen? The software will select the identical sections for the for throughout the member. Okay, so after that we have several parameters. If you go to parameters, you can define the effective length. You can see the kx, which is nothing but the effective length factor. So here for initially we do not change the kx or ky value. That means it will consider only the default value as 1. Otherwise you can also select the value of kx is defined directly. You can give your this kx ky value manually, or you can select the conditions. We have this braced frame, unbraced frame, so you can select here, and accordingly the software will calculate the effective length factor. So for now I'll keep it do not change the kx value or ky value. That means it will calculate that means it will assign only the default value of effective length factor. And if you go to torsion, you can also include the torsion in the design. So you can check beam for torsion and click on OK, maybe for all selected beams. Now if you go to AND conditions, now if you go to combined beams, here you can see we have defined the restraints here. So let me in case of 3D structure, you can define this restraints automatically. So why we need this restraints? Suppose in this end column we have this lateral support. So if you see the local buckling of these members, it will be from point to point, as we have this lateral restraints here, as we have this lateral members here. But in the middle column we do not have any lateral support. So in that case, if you see the local buckling, it will be as a whole from this node to this node. So that's why we need to restrain these intermediate nodes. So in case of 3D model, it will be doing automatically, but in case of 2D, what we need to do, we need to define by ourselves. And as we, in case of 2D model, we will not be modeling the lateral members here. So in that case, we need to go to any of these selection type, maybe by start and end of the beam, and you can restrain the buckling, the major or minor axis buckling, or you can also restrain the flanges, the positive and negative flange. You can see restrain plus Z face and minus Z face. So you can do that. So now you can select this manually in case of the 2D structures. I'll show you after the after this 3D cabin how we have assigned in the 2D also. So for now it will be automatic, and if you click on define, it will be assigned to all the beams. So after that, what we have to do, we just have to click on compute and click on OK. You can see the design summary, the deflection results, the slenderness, the axial force, okay, and for all the particular members, or you can see particular sections it is showing. Okay, so now if I click on close, you can also see the detailed result. If I right click on this column and click on detailed result for beam, click on OK, it will show you the detailed result for the critical combination. You can see the design combination is 9, and it will show you the results. You can see the moment, M3 moment, the axial force, the axial distortion, the combined stresses. It will show you the bending moment diagram also. Here we have the section that we have assigned in the column, and you can see here in case of this column, as we have provided these restraints, it is considering the unsupported length as 3, and you can see this the effective length factors that we have kept do not change, so it has considered the default parameters. Now if I click on close and I'll select this column at the end column, and I'll click on detailed results for beam. Okay, in that case, if you see the unsupported length, it is showing you 1 because it is considering the unsupported length from this node to this node. So this is how you can this member restraint option in this combined beam will help you to get the restraints, the member restraints automatically for the calculation of proper unsupported length for the members. Okay, so you can also check the detailed result by going here. If you go to results and display detailed results, suppose I'll select this rafter member and click on OK. Here you can see it will show you the detailed result, the unsupported length, the kx, ky, the moment diagram. Here you can see the shear, moment, M2 and M3, the deflection, axial force. Okay, so as we have included the torsion for the beams, you can see here the shear torsion stress, maximum total shear torsion stress is calculated. So, and normal torsion stress is also calculated here. You can also see the capacity. If you go to results and display capacity, check this color by capacity. You can select the result type, maximum of all results, or you want to select only slenderness or only deflection. So I'll go for maximum of all results. If you want to exclude the slenderness, you can check this, or if you want to include the slenderness, so I'll uncheck this and I'll click on OK. So including the slenderness, you can see the capacity here. You can also see, if you go to results and if you go to display section summary, you can also see the section summary, what type of sections we have assigned and what is the total length we need, what is the total weight of the structure. Now we have assigned this node number. If you see this node number 29 for the sway calculation, right? So if you go to sway here and display sway values for current sections, you can see here we have got the sway, which is 1.069 for the combination 11. So you can see here the sway also, which is nothing but the deflection of the total structure, and it is showing you the value in this node as we have selected this node number 29. So you can also calculate the drift if you want from there. Now in strap we have a very good option to optimize the structure as per for the control of sway. That means suppose the structure is crossing the limit for the lateral sway, or you can say the displacement. So in that case, which member we need to increase the member sections, we do not know. Maybe we'll try with changing the column, but in that case maybe it will more steel will be needed, or if you change a small bracing, in that case also it will be corrected. So we do not know exactly in which members we need to change. So in software we have this automatic sway. So if you select on this select sections according to sway limit, you can set the allowable sway limit, and you can click on OK. So what it will do, it will automatically assign the appropriate section to the required location, which can control the sway up to the limit. So this is a very good option that we have in strap. You do not have to worry about, because exactly we do not know in which members will be assigning the sections and what is the required section. Maybe we'll be assigning some section which is maybe higher steel will be required in that case. So this is how we can analyze and design a cold form steel structure using strap. In strap there are different automatic process, but again this process is totally depending on the input that we are giving. There we need, if we give garbage, then it will be giving us output as garbage only. So obviously the engineer's input is very much important, but what so the software does, the software will do the job very easily. And as we have different automatic optimization process and automatic load definition process, so it will ease our job, and it will increase the efficiency now of our work. So now I'll show you a 2D frame where we have also assigned the member restraints, so it will be easy for you to understand. If I go to models, I'll open this 2D wall panel. Here you can see the 2D wall panel that we have created, and I'll go to steel directly, and I'll open this combined beam. Here you can see these restraints are provided manually. I'll delete one here. Maybe select by window. I'll select this member. So I have deleted here. Now in this case you can see this is a middle column, so we do not have any lateral support, but in that case the outer column will be having this lateral supports here in this node. So in case of the buckling of this member, it will be from node to node, but in case of the middle column, it will be from this node to this node, that whole as a whole. Okay, like this. So that's why in that case what we need to do, we need to restrain this node. So for that, if I go to by start and end of the beam, now the best thing here is you can see exactly whether you are doing assigning this in a wrong direction or not. Maybe I'll select this major axis restraint, I'll define, I'll select the start beam and end beam. You can see now it is showing in other direction, so that means the restraint is not correct. So you can see, you can easily visualize this thing. So what I'll do, I'll change this. Again I'll click on define, I'll select this. Okay, let me first delete the restraint. Now I'll define, select start and end beam. Now you can see we have assigned the appropriate restraint at this node. So this is how we can visualize the restraints that we are providing, and it will be easy for you to understand, and it will reduce the chance of mistake here. So now suppose you are working in STAD, some people are also working in STAD, and what you can do in strap, we do have option to import the STAD models actually. So if I go to utilities, and you can see here we have this option, convert STAD input file to strap. So I'll select this. I have this STAD file, so I'll select this STAD test and click on open. You can see this stat file is added here, std test. Now if I go to geometry, and if I go to the isometric view, you can see the whole model is imported here. As the stat pro is itself is an analysis software, and we have imported the file here, the stat file here in strap. So in that case, the member releases, and all the things will be imported automatically. Okay. And suppose you are some people are also asking whether we can import the structure from vertex bd or this kind of 3D modeling, or you can say framing softwares or not. Yeah, we do have option to import the ifc files also. So for that we have a separate module. If you go to here, and we have this auto strap module. If I open this, I can click on file and import ifc file. I'll select the ifc file from here. So here you can see this model is created in vertex bd, and it is imported exported as ifc file. So this ifc file we can easily import to strap for the analysis and design. So after that we'll click on continue. We'll select the folder in which we want to save. Maybe click on select. I'll name it maybe example ifc and click on ok. So now I'll close the strap, and I'll open the strap again. And you can see this IFC example IFC is added in the model list. So I'll go to geometry, and you can see here in the isometric view, this model is totally imported here. You can also see the rendered view. So in that case, you need to make some changes. You need to do some corrections also, as the IFC file is just a model file. So it is not the analysis software if, like the Vertex BD or whatever software using for framing. So it is not analysis software. So we need to change some parameters, or maybe do some corrections. All these corrections, what we need to do, we have a separate course on cold form steel design on using strap in our platform, which is campus.ramcaddsys.in. So in that we have a complete course on cold form steel design using strap, where we have explained all the process, how we need to do the corrections, and what are the things we need to do for in this case. So you can always check this. We do have a 10% discount on this actually. So now this is how you can import the IFC files also from Vertex Video or whatever framing software you are using. So this is the beauty of strap. Actually, you can import structures from anywhere. You can do the analysis and design, and you can also export it. So yeah, we have no issue in that case. So yeah, this is it.
Now, I will request Mr. Srihari to share his experience with us. We'll get to know from him what his experience in the field of LGS, and what are the projects he worked. So please, sir.
Thank you, Sandeep. I hope everybody can hear me.
Yes, sir.
Yeah. Okay, let me first share my screen, and let's start from there. 1 second. Sorry. So yeah, let's share the screen. Okay, can you all see my screen? Hello? Can you all see my screen?
Yes, sir. We can see. Yeah. Yeah.
You can, right? Okay. All right. Good evening, ladies and gentlemen. Thanks, Sandeep, for a great presentation. It was a very, very informative as well as a very detailed presentation. As Sandeep has already introduced, I am Srihari Desai. I've been working for StrutCAD Design and Engineering for over a year now as a technical manager. I'm a structural engineer by profession and have worked over a decade in LGSF sector around the globe. In today's presentation, I'd like to share with you a couple of projects that I've worked on and the complexities I have faced during the experience and how I overcame them. Before we move into the projects in detail, I would also like to share my views on significance of having a experienced structural engineer and a sophisticated structural software. On the contrary to a popular belief that one click can produce an efficient design solution. Well, to be honest, there is no one click solution. Even if someone promised you for one, I can guarantee you that factors like economy, safety, sustainability wouldn't be met together. So basically, what the point here is, there is no one-click solution, right? I've used this phrase many times to my clients, my trainees, who expected a single button, would completely automate the design process. There are a few softwares, in the market promise this, but in turn, it brings a bad reputation to LGS builds as problems occur during the lifetime of the structure. Okay, on the day of handover, it looks really good and no problem at all. But during the lifetime of the building, you get cracks, you get unwanted deflections, you get so many things that happens over the time of the building, and that gets a bad reputation to LGS builds, right? So what I feel is, if you have the right software, very experienced engineer, he can produce the right design, and you construct it right on site, LGS builds will not have any issues for at least 50 years to 60 years. It's as efficient as steel. In fact, far more better efficient than hot rolled steel and concrete, because you can change a lot of variables in your design. For example, you can change the mu value for your heat transfer. You can change the sound transfer efficiency. So all these things can be changed as per your requirement. But in RCC, you can't do that, right? You have concrete, and it has a set of values that you have to stick to. But with the LGS, you can change the infill materials, and based on the materials, your values change. So having the right engineer and the right software is very important. Due to rapid growth in the sector, right? We are lacking the trained person, even in design or site. I've seen people welding LGS on site. You all know that light case steel building, as name suggests, is a very thin steel. It's 1.5 mm, and people weld it on site. Okay, I've seen welding, and I had to reject the design because they were welded. Once you weld, you don't. First thing, it's a very thin steel to weld, and there is no galvanization. Galvanization is out of window, so you end up having steel that is not galvanized. So you can't expect that to stay without any corrugation for a long time, right? Especially in the seaside areas like where I live, steel gets corrugated within no time. So galvanization is very important, and you need to make sure that galvanization stays on the light gauge steel when the project is handed over, right? That had a truss that is 200 deep, right? The truss is 200 deep. When in LGS, to manufacture and to assemble, it's a very complicated process, right? Because you only have 200 deep. You have to fit members in between, so it'll take a lot of time. Instead, putting a 200 joist would have been a lot easier solution to do it on site. Same way, connecting these together, there are a lot of easier ways to do it than general perception of LGS. So uh, getting the right solution is very important at the very basic stage of any project. Next, safe and durable structures. Of course, you use the right tools, you use the right person, you are bound to get safe and durable structure. As Sandeep was mentioning, garbage in, garbage out. If you your input is wrong, your output will be wrong. Now, these one-click solutions say, "Oh, our software is provide you solution where you just in one click you can you model the building. With one click, it will say pass or fail." But that is not enough to get the safety and durability, right? You have to consider a lot more factors that go into the safety of a building. Now, as I say, structural engineering is a vast field. Okay, this is a vast field, and there are a lot of variables that go into a design. Okay, and I'm sure the software cannot determine all the values. Now, we have seen in the presentation by Sandeep uh, the complexity of a small building. Let's say it's not a big building that Sandeep was showing you, right? But the complexity involved in it, the variables involved in it is a lot. Okay, now say you have a 5-story building, or let's say 4-story building, or even for that matter 3-story building, and you just go through the software and say, okay, one click, it says pass and fail. Okay, you're good with it. It says pass, and you print it and you erect it on site. But you don't know what are these variables that software has used, because you don't have an option to change it, right? Software, as I said earlier, it's just a tool that you're using, but you need to have human touch to all these softwares. And I don't know if younger generation agree with me on this, but automation to maximum level where human touch is not needed is not what I prefer, especially with somebody else's life. These builds are somebody else's property, and hundreds of people will be staying there if it's a big building. So you can't risk on one software to just give you all the output. So you need to check manually, one by one. Of course, it's a time consuming process, I don't deny that, but it is for a greater good, right? Now, also optimum design of other components of the building. Now, LGS builds doesn't just mean studs which are act like column, or trusses or joists which act like beam. It's not just about that. LGS build is a lot more than that. So you have many other components that all come together for to have a great build. For example, you have bracing. Okay, you have bracing members. You have connections. Now, as I say, all the LGS members are connected using screws. Okay, they are not connected using bolts. So you all the members are connected are pinned. That means there is no moment transfer. When I say this, when I say there is no moment transfer, that means your frame is not having any stability. You need to find a solution for the stability as a whole structure. Okay, it can be through bracing. It can be through hot roll frames that you put in between. It can be through core walls of lift shafts. There are a lot of ways to get the stability, but those things cannot be done by software on its own. It's engineers input that will decide all this, right? So optimum design of other components and buildings, stability, sliding and overturning checks. So no software does sliding and overturning checks by itself. You need to do it manually. Okay, or you need to do it by Excel sheet, or you need to do it because it changes for each and every project. Okay, so sliding and overturning checks are depending on the sulfate of the structure. Now, LGS is a very, as its name suggests, it's a very lightweight structure. So sliding and overturning checks are very critical, especially when the wind loads are very high. Now you could have seen in a few videos where you have heavy winds and structures overturned, or structures were sliding through the roads. So all these things you have seen in the videos, right? These are basically because it was not designed for stability, sliding and overturning. Mostly those were designed by a single click softwares. So of course you don't want that to happen to your building. So that's why I'm saying there's no one click solution. You need to use proper engineer, proper software, sophisticated ones. Invest in these things that will pay you back in long run. Okay, you are even the owners. I don't know if we have the machine owners in the crowd, but my suggestion would be, invest in the right engineer, train him. It doesn't matter. Invest in training your staff, and get the right software to him, to her, for that matter, any him or her, and those engineers and those softwares will pay you in long run. Okay, the investment is not gone waste. They will return in a big way, because you're investing hundreds of thousands of dollars on a machine, but you don't want to invest in a person. I've seen clients coming to me and saying, oh, why do you charge so much? Yes, we charge so much because we have spent a lifetime doing this, right? So yeah, let's go ahead and look into a few of our projects. So what I have here is I have 3 projects that are complicated and 2 projects that are easy. I'll explain you why I have put 2 easy projects as well. Okay. Now this is one of the complicated projects that I worked on. It was in the UK. It's a G+4 residential structure. It had, well, put it in this way. This was I would say a structural engineer's light gauge steel structural engineer's nightmare. I'll tell you why. So this had everything that you don't want in an LGS structure. Okay. Now see this. So these are called fins. I don't know if you can see my cursor, but I bet you can. So these are called fins. So these were all done with LGS, including the building itself. These were all done with LGS. So I think the developer designed this for RCC. Then they changed it to hot rolled steel. Then all of a sudden they wanted to do it with LGS, so they came to us. All right. So the way this was done was these are all braced frames. Now, when I say braced, they're not X-braced; they are K-braced. So they look more like a truss, and they are attached to the wall. So wall itself has cantilevered out here. They are not just attached to the wall; they are the wall itself, wall piece itself that is cantilevered out. Same way, if you see ground floor is not same as 3 floors above. So what we did was, again, we introduced a deep truss that would hold the cantilevered part out. So in each of these walls, and those trusses went all the way into the wall, and wherever we had high axial load on the truss, we introduced other members, additional members there to compensate. Okay. Same way, if you look at the top floors, they both are not same as the below floors. Okay. And the client had restriction on the depth of the floor, and we couldn't use anything more than 200 mmd. Okay. That's when a software like Strap came into picture. Sandeep had showed you the Crosec, right? Where he added a few sections and came to the combined section. Of course, we used that kind of combined section to support the walls above in the floor below. Okay, we couldn't use hot roll, so we have done that. We have done that. Same way, it's the same to this one. So there was a different combined section that were used here. Of course, the spans were changed to suit the plans. These spans, of course, we had to change the spans, and no hot roll was used to cut the spans. Okay. Good thing about this project was there was no large spans. They are all like not more than 4.5 meters, not more than that. But it also taught us the strength of LGS. How much can you stretch the boundary of LGS, and it was a very important project for us, and the learning curve was excellent. We learned a lot in this project, and I should appreciate the design team as well that worked on this project, because we had a lot of rules that they had to follow. For example, all the studs had to align with the joist, and each and every point load should have double studs that will go from top floor to the ground floor. So there were so many instances that design team had to sit together with us and come up with a solution to this. It was a very good project. Next is this one. This was a care home. There was it was a care home that was for the elderly people. Now these rooms that were in these 3 floors were pretty straightforward. They were not more than 4 meters, so we used joist, and it was pretty straightforward. But this part here was complicated one, because we couldn't use any hot roll for this long, and this was a very big gable wall, so the wind loads were high. So we had to find a way to come up with a solution for this. So we introduced a truss here, then we had to brace it back to the building. So things were taken, we had to introduce not hot roll, but with LGS we had to introduce a new type of Simpson strong tie ties. So all those things were done, and we used even the brick wall that was adjacent to the steel frame. We designed the brick wall to take the lateral load as well. Okay, same way this one, it was a project for a Saudi Arabian client of mine, and it was a building for Ministry of Housing Saudi. Now they wanted it to be pretty straightforward. They wanted it to build in LGS for the speed of construction. So what we couldn't do was we couldn't introduce a lot of hot rolled. Then we couldn't introduce a very complicated kind of connections and trusses. So what we did was we introduced joist instead of trusses. So we built this in a very quick time. Also, as you can see, the walls don't line up, so we had to find a way to transfer the loads through the walls and studs. So yes, we introduced combined sections under these. So yeah, this was a very good project as well. Now next two projects are easier ones. So when I say easier ones, that means they were actually made for LGS. When I say this made for LGS, that's because, so next to this and the next project, we were involved from the initial stage of the project. That means we were involved when architects were still in the drawing board. Okay, so we could also check the drawings, and we could also guide them, saying, okay, this was a bit complicated for LGS. Can you do it this way? Can you do it that way? We had a lot of discussions and came up with a building that is optimum for light gauge steel. So this is what I suggest to my fellow colleagues and my fellow members in the crowd, right? Talk to engineers, talk to architects, make them sit together and develop the solution that is more optimum for LGS. Now, when you can't take LGS and say, okay, build a 10-story with just 5 columns in the whole building. No, you can't do it. And, yes, you can try it with hot roll, you can try it with the RCC, but LGS, it's not the case. So you have to make sure that your building is optimum for LGS, right? So this was a school that was built in the UK. Now these walls were 5 meters high, and that was a requirement because this was more of a playground for kids, indoor playground. So this was 5 meters. So we had to introduce the wall trusses in between to make sure that wall doesn't move. And then in parapets we had to introduce wind posts, because the parapets were these parapets were almost like 2 meters without any supports in between. So we had to make sure that we introduced wall post. So but other than that, the whole building was very user friendly for a LGS structure. Now this one, so these two projects, I don't have the actual pictures because I was by then I was away from the company, but yeah, these are the pictures I have as of now. But this is again G+4 accommodation. It's a student accommodation. So these type of structures are very useful if for LGS construction. So when I say student accommodation, they don't need a fancy wall in between. They don't need a curved wall in the main hall. They just need a square box. I'm not saying LGS is just for a square box structure. You can have a curved wall, but as I say, when I say curved wall, you can see this had a curved wall over here. So the whole curved wall, right? The whole part of this was just LGS studs. Now imagine if you have 5-6 curved walls, you're spending a lot of steel, right? You might as well go with RCC, right, or a hot roll. I'm not saying you need to go with a box every time, but sitting with the architect and discussing with him. Architects understand the complexities. Even architects understand the advantages of LGS, disadvantage of LGS. Now, any system, there is always advantage, there is always disadvantage. So we need to reduce the disadvantage and increase the advantages, right? So this project as well, this was a 4-story project. We were introduced to this project from the very basic stage. So what we did was we sat with architects. We strategically placed the staircase to give us the maximum lateral stability for the building, right? Then of course we introduced the X-bracing, but then also there was a hot rolled steel core from the staircase that was strategically placed in order to get the lateral stability for the building. Okay. Yeah, that was more about, because I only had 10 minutes, so that was more about the projects. And now at StructCAD, we do several things with LGS, right? We do turnkey design solutions for LGS builds. That means we can produce the structural calculations. We can to do any code, to be honest. We have projects, we have clients that we have given structural calculations in the UK, in the Europe, UAE, as well as USA. Now with USA, I know that there is a complication of getting the structural approval from the local authorities or a local structural engineer. So my clients, what they do is they come to us, they get the structural calculation ready, then before they just go to the local structural engineer. He just has his checks, and if there's any questions, he comes back to us and then approves it. So that reduces the local structural engineer's time. That means that is saving him that's saving the client a lot of money, right? So that's about structural part. We also have a team that can model vertex, that can model any complicated vertex models and produce CNC for the machines. So that's turnkey design solution for LGS builds. We also look into production, quality control, and management of LGS builds. That means at StructCAD, we have collaborated with a couple of machine producers who can produce the sections based on our design. Then during this production process, we have our team that will be going there, making sure the quality is controlled, and then they use the right steel, right kind of models, files, and also we manage the LGS builds. So we have a team that can go to site, guide the local teams to to build the LGS in the right way. We also have a drafting team that can do CAD drafting, details development for the LGS projects. So when I say detailed development, we know that every contractor will have his own details, right? That's kind of his strength. Now you can have two contractors who can build the same building in 3 months, or one in 4 months. The difference is they have their own set of details that is very efficient, and the second one doesn't have that, right? So we can develop those details for our clients in CAD or in PDF. So any way they want, we can develop that details as well. We also provide one-to-one training for structural design of LGS builds. So apart from LGS, we also undertake design of reinforced concrete, hot rolled steel, masonry, timber structures, pad foundations, etc. This has been taken care by my colleague, Ms. Sweetie Somshekar, who is also the founder and managing director of StructCAD Design Engineering. She is also responsible for mixed construction of LGS with hot rolled steel. So whenever there is a potential risk or a potential problem associated with any structure, she is of great help, offering her experiences and arriving at an economical and safe solution. She has over a decade of experience across the UK and UAE. She has also worked on deep foundations for some reputed projects in the UAE. When I say deep foundations, that means deep piles, the retaining structures. So even we can using her experience at StructCAD, we have a great team doing this as well. Now we also have a team that is dedicated to BIM integration solutions. When I say BIM integration solutions, of course in the UK, the BIM integration is picking up, which means now people have to look for solutions that are BIM compatible, right? So we here produce a workflow for them, or workflow for our clients, that integrates BIM to BIM. That means we suggest the softwares, we suggest the training schedules, we suggest the workflow. So all these things can be produced by StructCAD Design and Engineering. So you can of course get in touch with me if you need any of these services through my email ID there, as well as I have a phone number there. But last but not least, I would really like to thank Ramcat System for providing me this opportunity to talk to my people in my industry, and I have a poll that I have put in where people can vote if whatever I said was right or wrong. Of course, I need your feedback to make myself better and the company better. I really like to thank Ramcat System for providing me this opportunity. And yeah, if does Sandeep want to take over
Yeah.
and start
Thank you.
off?
Thank you so much, sir, for sharing your experience and sharing the projects that you have done. It is a really great to see those projects and what are the approaches there. So I think we can get some questions regarding the technical questions. If anyone have technical questions, you can always ask there in the chat. And yeah, we have already got some questions, and Ravindra Reddy sir has already answered those. Thank you so much, sir, for answering those questions. Actually, I was in the presentation, so yeah,
Yeah,
thank
if
you.
you have any questions related to the projects, or if you have any questions related to the slides that I've shown, or anything that is related to LGS, you can all you can ask.
Yeah, you can ask in the chat. We'll be taking the questions.
Oh, there is poll as well, so please can you
Yeah,
it'll be helpful for us to if you can use the poll option and vote.
so so are you guys having questions regarding the project that sir have shared with us, or any technical questions regarding LGSF? So you can put in the chat box. You can also visit our training module. You can see. Okay, so what is the difference?
Yeah, I'll stop sharing my screen.
Okay. So we have got one question, which is what is the difference between Vertex PD and Strap softwares? Okay, I think this is a very simple thing. Strap is nothing but the analysis and design software, and Vertex
Yeah,
BD is mostly, I think it is mostly about the detailing, or you can say the modeling
yeah,
of the. Yeah,
it's a framing
yeah,
software.
framing.
So Vertex BD is a framing software which cannot. Yes, there is a module for engineering, but again, Vertex BD is, I would say, a framing software, and Strap is basically analysis software uh, used by engineers to analyze and get the results. While Vertex is more that comes after the Strap analysis. So what I feel is the workflow should be is you start with Strap software, you come with the section sizes, then you go to Vertex BD and produce the members. Sorry, produce the frames. It's automated framing software, Vertex.
Okay. So yeah, anyone else? If you have any question, you can also visit our website, ramcats.in, and also we have a training module on different. We have training module on Strap, on different softwares, foundation design of Plaxis. So you can visit our campus.ramcats.in, and in that website we'll be getting all the training sessions, or you can say the training modules we have.
So
So I think
any other questions?
yeah. Any other questions? If you okay. Okay, so I think we can end this now. Okay. Yeah. So thank you, Sherry sir, for sharing your experience. Thank you, Ravindra Reddy sir, Aditya sir, for only because of them this webinars are possible. And I'm the member of Ram Caddsys Private Limited, and thanks to them for allowing me to conduct these sessions. Thanks to all the members of Ramcats family. Thanks all of you who have joined this session, because without attendees this kind of webinars are really useless, because yeah, we need people to get awareness, or people to learn from our webinars. So if more people are joining our webinars, so this is the success of our approach actually. So thank you all of you. And
Thank you.
Yeah,
Thanks.
thank you sir. So yeah, I'm we are signing off. Thanks.
Thank you. Thanks.